All right, so looking at number 9, this is really a problem where there's some real world connection to math. A lot of times students will say, what's the point? What, I have to learn this? When am I ever going to use this? But figuring out what we'll call the unit cost or the unit price of something is something that plays into some kind of real world stuff. And what it does is in making a comparison. Do I get 30 16.9 ounce bottles, or do I get 24 20 ounce bottles? So this is more bottles, they're smaller. This is fewer bottles, but they're bigger. And then it's like, well, which one's the better deal? Well, we have to be able to figure out, we have to be able to kind of compare per ounce how much each one is. And by the way, next time you go to the grocery store, when you go to the grocery store, every single price tag that's on the shelf there, somewhere in the corner you'll see a unit price. So let's say something's $2.99, and then you'll see a little .06 in the corner. So that's telling you what we're just getting ready to do. So what I want to do with this is that I want to figure out the cost per ounce. So basically, how many ounces am I getting by getting the whole case here? How many ounces am I getting, and how much is that going to cost me? Now, what I have to do here with this one, so the cost is $42.36, and then the number of ounces, I have to figure out how many total ounces, because it's 16.9 in one bottle, but then I'm getting 30 bottles. So to figure that out, I'd actually have to figure out the total ounce. Right? So total ounces, I'd have to multiply the two. I'd have to take the 30 bottles that are 16.9 ounces apiece and then multiply those. So we can use our calculator for that. So we'll say 30 times 16.9, and we get 507. So what that means is that there's a total of 507 ounces in this whole container. Now what we're looking for is the cost per ounce. So what we would do is we would divide it. So we're going to divide 42.36, which is the total cost, divide that by how many ounces we're getting. So we're getting a total of 507 ounces. And what we get is .08 and then a bunch of decimals. Well, we can just count out, since we're talking about pennies here, right? We're talking about cents. We just cut it off after 2 decimal places. So let's just say .08. And since we're rounding, we do a little squiggly. So we'll say approximately 8 cents. Right? So what that means is that for each ounce, it's going to cost you 8 cents. Right? And then so if we multiply that out, if we said 507 times .08, we'd get our cost, which would be 42.36. So let's do the same thing for this other container, the container that had fewer bottles, but the bottles were bigger. The cost on that is $27.99, and we got to figure out the total ounces here. So the total ounces, you get 24 20-ounce bottles. So 24 times 20, right, which is going to give you 480. 24 times 20. So you get a total of 480 ounces. Right? So you're getting less ounces, but it also costs less. So maybe it ends up being a better deal. So we're then going to take the total cost, $27.99, and divide that by 480. And you get .05. And actually, we're going to round to 2 decimal places. So since the number after the 5 is bigger than 5, so we'll round up. So we'll say approximately 8 cents. So we'll come back over here. So approximately 8 cents. And so then the question is, well, which one's the better deal? Well, on this particular question, option B would be the better deal. And what we would say is we'd say something to the effect of, well, B is the better deal. It's the better deal. B is the better deal. And why is it a better deal? Because the cost per ounce is cheaper. So for this one, for B, you're only paying 6 cents per ounce, whereas with A, you're paying 8 cents per ounce. So you're paying 2 cents more per ounce. So if we're looking for the best deal, then that one would be B. And by the way, what's your for those of you that are familiar with Call of Duty or one of those types of games, is that if you think about a kill-death ratio, this doesn't have anything to do with Gatorade, but I'm wanting you to see another example of where you see this kind of calculation. If you think about a kill-death ratio, you're doing the same thing. You're taking your number of kills, dividing it by your number of deaths, and then you get a number. So if that number is equal to 1, then that means that you have an equal number of kills and an equal number of deaths, right? But if your KD, or your kill-death ratio, is less than 1, right? Let's say it's like 0.86 or something like that. Then what that means is that you have more deaths than you do kills, right? And of course, if you play the game, you probably already know all of this, right? In 1.2, let's say it's 1.2, you have more kills than deaths. So that's that's the math that you do, and you don't even realize that you do it. So I just wanted to throw that in there, as that's another example. The kill-death ratio is exactly what we're doing here, but instead of talking about kills and deaths, we're talking about dollars and ounces, but it's the same idea. All right, so go ahead and pause now and try 9.2 and 9.3. All right, so let's see what you got. So for A, you should have got $1.22 per ounce, and for B, you should have got $1.67 per ounce. So which one's the better deal? Well, the better deal would be A, because you get more for your money. And then for 9.3, should have got 33 cents per ounce for the Oreos, or at least the 12-pack, and then 40 cents per ounce for the 24-pack. So A ended up being the better deal because it was 7 cents cheaper per ounce. All right, so hang in there. You're almost there. Let's move on to the last question, number 10.